Okay, we're back to linear programming and we're going to do this one more example. So let's read the problem. 2 different blends of coffee are to be made. 75 pounds of Colombian coffee and 120 pounds of Kona coffee are available. A can of blend A is to contain 4 ounces of Colombian coffee and 12 ounces of Kona coffee, while a can of blend B is to contain 8 ounces of each kind of coffee. The profit on a can of blend A is a whopping 20 cents, and the profit on a can of blend B is a whole 38 cents. How many cans of each blend should be made to maximize profit? Use the complete linear programming process. Okay, here's an editorial note. I've been using these same problems for probably 25 years, and so we haven't seen these prices raise in the problems, but chances are the profits would be a little higher today. You'll notice that also when you do your homework, there's a problem about people making $4 an hour. So I remember when I made $4 an hour, but luckily minimum wage is a little higher than that today. Okay, so let's go ahead and identify our variables. So this is tricky for people. You really do need to identify your variables before you get going, or you can get pretty confused with this problem. Remember to go back to the question, how many cans of each blend should be made? Okay, so how many cans of blend A and how many cans of blend B? So I'm going to let A equal the number of cans of blend A, and I'm going to let B equal the number of cans of blend B. Okay, so now for the constraints. Well, let's start off with those invisible constraints. A is greater than or equal to 0, and B is greater than or equal to 0 because you can't have a negative number of cans. Another thing that could throw you off in this problem is that we have some things described in pounds and some things described in ounces. So you have to decide if you're going to work in ounces or pounds. I'm going to decide to work in ounces, and remember there are 16 ounces in 1 pound. Okay, so now the situation is they're using Colombian coffee and they're using Kona coffee. So for the Colombian coffee information, it's actually coming from different places. There's 75 pounds available. Blend A is going to contain 4 ounces. And blend B is going to contain 8 ounces. So you have to get all that information about Colombian coffee from 3 different places. So 4 ounces for every can of A plus 8 ounces for every can of B has to be less than or equal to 75 pounds. And if you take 75 and you multiply it by 16 ounces per pound, you get 1,200. And that is everything that has to do with Colombian coffee. Now let's come up with the inequality that has to do with Kona coffee. So there are 120 pounds available. We use 12 ounces in blend A and we use 8 ounces in blend B. Okay, so that means we have 12A plus 8B is less than or equal to, and 120 pounds times 16 ounces in a pound is 1,920 ounces. And that is everything that has to do with Kona coffee. So now we have our constraints, and let's write the objective function. And the objective is to maximize the profit, just like it was in the last problem. So the profit is going to be 20 cents per can of A plus 38 cents per can of B. Okay, so now it's time for us to graph. And so I'm going to label these inequalities 1, 2, 3, and 4. And for number 3, I'm going to go ahead and find the intercepts. So if A is 0, actually, you know what? For number 3, we can also simplify it. We can divide the inequality by 4. So we get A plus 2B is less than or equal to 300. That's easier to deal with. So if A is 0, B is 150, and if B is 0, A is 300. And then for 4, same idea, we can divide it by 4. We get 3A plus 2B is less than or equal to 480. And so for the intercepts, If A is 0, B is 240, and if B is 0, A is 160. Okay, so using quadrant 1 again, sorry about my crooked lines. I'm going to put A on the x-axis and B on the y-axis. And then let's think about a scale. We have to go up as high as 240. We have to go out as far as 300. So I'm thinking maybe if I go by 20s, let's check it out and see. So we would have 100, 200, 300, and then 100, 200. I think we can just barely make it there with the space I have. Okay, so for line 1, that's just A equals 0, so that's the y-axis. It's a vertical line. And we're going to label that with a 1 and plan to shade to the right. For line 2, that's B equals 0. That's the x-axis. Label that with a 2. We're going to shade that up. Line 3, let's go ahead and plot those intercepts. 0, 150, 300, 0, and then use a ruler and label that with 3, and that one is going to shade below. And then number 4, we have 0, 240, we have 160, 0, use a ruler. That's number 4, and that one's going to shade below. So today we're just doing simple ones. So yeah, this looks a lot like the last problem. It looks like a quadrilateral. It's attached to the origin. Nothing extra special. Just having to write the inequalities is the tough part. So let's go ahead and label these vertices A, B, C, and D. Let's find each vertex and let's find its profit. So A is 0, 0 with a profit of 0. B, we already found that earlier, that's the point 0, 150. C, I'm about to find. D, we found that earlier, that's the point 160, 0. And now to find point C, we need the intersection of lines 1 and 2. So we have, oops, not 1 and 2. What did I do? Should be 3 and 4, right? 3 and 4. Okay. So let's use the simplified version of these equations. We have A plus 2B equals 300, and we have 3A plus 2B equals 480. So if we subtract, the B's will cancel. So we have negative 2A equals negative 180. So A equals 90. And if we substitute that back in, we get B equals 105. Now let's look at the graph. Does that seem right for point C, that it could be at 90, 105? That seems logical that it could be. I didn't use a ruler. Okay, so now I'm going to grab a calculator and put each of these vertices back into the profit, the decision function, the objective function, and we'll see what we get. Okay, it looks to me like the profit is $57 for point B, $57.90 for point C, and $32 for point D. So the highest profit is made if they make 90 cans of blend A and 105 cans of blend B. Now you could come up with all kinds of arguments about the real world situation, like, okay, 90 extra cents. If they just sacrificed the 90 cents, they would only have to make one blend, blend B. Maybe that would actually be a better situation for their machinery and their employees and everything. And yeah, we could talk about things like that, but in terms of purely the math, the answer is 90 cans of blend A and 105 cans a blend be? Okie dokie. So, for your assignment, the problems on page 171 are just graphing systems like we did in our examples 1 and 2. And then there's a linear programming worksheet that has 3 more linear programming problems to do with the complete linear programming process. Thank you. Also, I have put my worked out solutions to these 3 on Canvas. So if you get stuck, please check the answer key. Thanks.